Hey y'all, coming to you from the international headquarters, ScottieDTV, but I was out at the 2022 SEMA Show, and they had a seminar out there that Mike Copeland was part of. It was called EVs Are Not Freezing Out ICE Vehicles Yet. A lot of interesting information about electric vehicles, hydrogen vehicles, zero emissions, all that stuff. I thought y'all would enjoy it. I enjoyed it. It's about an hour long, but it's really good information. Let me get the camera turned around and you can check it out.
The very first SEMA educational seminar workshop of SEMA. So it's great to see everybody here. Great crowd for 9 a.m. My name's Sean Holman. I'm not up there. I'm filling in. So I'm the content director for Motorfins Truck and Off-Road Group and the co-host and co-creator of the Truck Show podcast. And Rob called me up and said, hey, we need help with moderating a panel. I said, this sounds like a really interesting one. So we're going to dive into exploring the use of alternative fuels to keep ICE alive in this time of, in some ways, push electrification. And I think electrification is a really interesting topic, but I don't think it's the end of ICE by any means. So we've got some great panelists up here today. Do you guys want to start with Federico? Do you want to introduce yourselves and where you're from? These are some pretty heavy hitters in the industry, representing both Tier 1 suppliers and the aftermarket. And I think you guys will find this panel really interesting.
All right, thank you. Thank you for having me here. Federico Morales Zimmermann, working for Water, responsible for global product engineering, business development and sales. Located now back in the US. I spent the last 2 years in Luxembourg, in Europe, actually developing what we're going to be talking today a little bit, about the next generation of fuel systems on the gasoline diesel side, but also on the hydrogen side. So thank you for having me here.
Thank you. David?
Yes, very nice to be here. Welcome to everyone. So I'm Fabien Redon. I'm the Chief Technical Officer of Acadis Power. Acadis Power is a company based in San Diego developing opposed piston engines. And one of the benefits of the opposed piston engine is the ability to operate with hydrogen. So that's one of the new frontier that we're exploring. In partnership with the rest of the industry. I've spent most of my career in the Detroit region working for General Motors and Daimler, so lots of experience in car and truck industry. Thank you.
Thank you. Mike?
Hi, I'm Mike Copeland. I am the CEO of Arrington Performance and Diversified Creations. They're both performance companies. We're located outside of Detroit in Brighton, Michigan. Arrington is a Hemi-based company typically, so we build anything Gen 3 Hemi from a simple kind of lower performance rebuild all the way through 2,500 horsepower Hemis. So, and then Diversified Creations is a performance and off-road company. We focus on everything from putting a set of mud flaps on to a full ground-up car. And I had spent 26 years at GM in advanced engineering before I retired, and then ran Lingenfelter for 5 years, a little over 5 years. And then now I do this. So last year we debuted a 1948 Chevy pickup here at SEMA with a supercharged 6.2 running on hydrogen.
Right. Thank you, Mike. Tobi?
Yeah, hi everyone. My name is Tobi Burek. I work for Ricardo. Ricardo is a global engineering consultancy, and I'm a chief engineer in the engines group. Based in Detroit, Michigan, I guess I have responsibility to lead and deliver some of the bigger engine programs we have in Ricardo. We focus on anything from sort of light duty all the way up to submarine heavy duty, and programs sort of really novel prototype all the way through to production. One of the current programs is actually with Fabien and Acadis on one of their OP engines, and perhaps we'll talk about that later.
All right, thank you.
Good morning, everybody. I'm Andrea Landi. I'm the president of Landi Renzo USA. Landi Renzo was founded nearly 70 years ago by my grandfather. He was a pioneer in the eco-mobility. He built one of the first emission lab in the mid-60s when everybody around him was telling him, what, emissions, environment, like, what are you talking about? It's important, okay. So here we are talking about eco-mobility and alternative fuels in space. And yeah, globally, we've been working with passenger cars over here with Land USA. We've been on 13 years, mainly commercial vehicles, work trucks, natural gas, renewable natural gas, hydrogen. So yeah, we're again the provider of eco-mobility solution. We're very happy to be here.
Thanks, Andrea. Appreciate it. All right, so I'm going to start this off with a trick question, and I'll let you guys answer it. What is zero emissions? As we're being pushed toward this carbon neutral, zero emissions, there seems to be different definitions, whether it's tailpipe emissions or life cycle emissions. Maybe talk about those differences and what they mean to you guys. Whoever wants to take that.
I think nothing is zero emissions. I think that's the first thing we've got to understand. Even a horse breathes that CO2, so nothing's emission. There's zero emissions. And the focus, I think, at the minute, which is maybe a bit misleading, is on tailpipe emissions and that only. That's just part of the story. So internal combustion engine obviously produces stuff out of the tailpipe, whether it's burning hydrogen or natural gas or diesel or gasoline. But we need to think about beyond that. So there's the non-tailpipe emission side of things. So road tires, brake dust, and those kind of emissions. But also the upfront stuff. Where do you get the energy from? Where do you get the materials for the batteries from? And I don't think that's talked about enough. So zero emissions is a misnomer. Nothing is zero emissions.
I agree with this 100%. I mean, I think well-to-wheel is key in this analysis. I mean, you can't eliminate the pollutant emissions at the tailpipe by increasing the pollutant emission at the source. So I think this is key in this discussion. And I think the future world that we're already in it. The mobility technology is changing, and we'll all be in a world with a common denominator of sustainability. So that's the key. How do you get to a sustainable transportation? And again, I think you have to analyze the whole cycle.
Well, and I think important to what you gentlemen said was tailpipe, the source. There's also the manufacturing emissions of mining these supplies to build batteries or
recycling afterwards as well.
Recycling.
Yeah, what happening with cradle to grave? Yeah, the whole cycle of it.
So it seems like there's a semantic game being played with zero emissions these days, and I think what's really interesting is this panel here is these gentlemen represent really a broader level of thinking, a holistic approach to it, and not just diving on zero emissions. So with that being said, is there a future for internal combustion engines, and what does that look like in each of your lives?
Absolutely, I would say yes. Even though at BorgWarner we are committed to be carbon neutral by 2035, and we're accelerating the EV sector. Nonetheless, we are spending significant amount of R&D in the internal combustion area. Let it be, still on the gasoline side, still on the diesel side. Believe it or not, Euro 7 are coming up. Right now, the systems are not capable in doing so. We are developing systems they are able to do so. We believe, that there is a balanced approach to everything. Correct? There is a space for the EV. There will be a space also, a sustainable space in the market for the internal combustion engine, especially with fuels like hydrogen. Right? And I think important is the technology openness that we have to be. It's important. Secondly, is the education that we have to do to the governments, to the legislators, to make sure they deploy laws in place that makes really sense for the environment.
Anybody else want to add to that?
Yeah, I think I want to add some comments. So in the naming convention of zero emission vehicle, there's emissions, there's CO2 emissions, which is what causes global warming, and then there's criteria emission. So I know in California, I'm sure you've heard about NOx emissions and the smog in LA. So there's a big effort to reduce these emissions. Right now, they're not targeting zero emissions for IC engines, but they're targeting zero emissions as a whole. The only solutions that right now produces zero emission where the emissions are created is EV. But as we talked about, there is a much bigger picture that we have to keep in mind. I think the regulators are basically going for the perfect solution, but maybe not for the best solution, right? There is I think a trade-off between having the perfect vehicle that has no emissions and actually making the biggest impact in the environment, which is to actually as many vehicles with very low emissions as possible. So perfection versus best is this something where we need to really help the regulators understand what is actually the best solution to reduce emissions and achieve the goals.
I think one of the challenges is, and one of the things that everybody tends to look at differently, is where do you snap the chalk on, right? I don't think anybody goes out in their backyard with a scoop, digs up a bucket of oil, and goes out and pours it in your car and drives it away, right? But today, everybody ignores that part of it. Right? How do you really get energy? How do you take oil out of the ground? How do you process it? How do you transport it? How do you do all of those different things? What's the impact of that? It's the same situation with electric vehicles today. You know, they talk about their zero emission, but have you seen what they have to do to get the lithium?
I mean, you're essentially offshoring your waste, filth, and pollution
Right.
to somewhere else so that you can feel good about it at home.
Yeah.
And that's great if you want to have those blinders on and take the zero emissions marketing, but it's not great because you're not necessarily cleaner than internal combustion. You've just been told you are, and so it's really important to understand, to your point, the entire process.
It's playing by the rules, right? And the people that make the rules, in my opinion, aren't quite honest about it as they could be, right? They pick this part and they say this is this, right? So here's my philosophy about the whole thing. There are, depending on whose numbers you use, but if you use SEMA numbers, there are 290 million internal combustion powered vehicles in the world, okay? More than 90 million in the US. What are we gonna do, scrap them all? You know, they got a law in California, you can't buy a generator, right? What if it's gasoline powered? There are no others. I mean, it's diesel or gasoline, so, you know, what are you gonna buy, right? It's okay, it's great to sit around in a room with a whole bunch of people that really aren't impacted or don't choose to look at all the facts and make decisions. No more ICE engines after 2035, right? No more this, no more that. The reality of it is that the world still has to move. The people that are here, that are sitting up here, and I'll include myself in that, we're focused at a better solution, and we're gonna have to face not just the challenges of creating it and making it function and making it work. We're gonna have to educate and bring all of our legislators and the people in government along to get them to understand, right? So I have a truck, we call it zero, all right? When we measure the exhaust pipe, as long as we can control oil coming out of the crankcase ventilation or anything that bypasses the rings or the valve seals, by the standards we measure by, it is zero. There's no carbon monoxide, no carbon dioxide. We control hydrocarbons. You know, the only output is water, which turns to steam. And once the exhaust comes to temperature, you don't see anything, right? If we fire it up cold, you get two little spots on the ground. And as it warms up, it sits there and warms up, it will actually evaporate those spots off of the ground as the exhaust comes to temperature. So, by definition, in certain areas and by the path that we're taking, it is zero emissions. How do you get hydrogen? A whole nother story, and everybody up here has got lots of experience with that, and the technology is changing as fast as time can move.
And I would say that we're all gearheads in this room. I think that's why you're at SEMA. And you know, you look at the different fuels that have motivated automotive. Steam power, electric power was actually huge back in the 1800s. Gas, diesel, back to electric today, hydrogen. And I want to make sure that when you guys walk away that this isn't a bashing where we're going kind of thing. I think as gearheads, we love anything. I think EVs have some incredible potential, fun to drive. I think that hydrogen is a fascinating fuel. I think, you know, all the things that we look to, burnouts and noise and stuff like that, you still do. But it's great to be able to learn and really approach it from a whole worldview standpoint. Now, you guys have talked about hydrogen, natural gas is another one. Why those fuels, and how will they be used to decarbonize, if you will, the internal combustion engine?
Well, Sean, I want to go back real quick because you said, okay, we're here, to talk about pretty much everything. We're all the car and automobile enthusiasts. And like you said, we're here to find a better solution, and that's the whole point. Again, I think that the common denominator moving forward, that we started already, is sustainable transportation.
Sure.
Okay. So we really have to look at the whole picture. And you just mentioned electrics are great and for certain application, and I agree. And there's just, in the future, I think we'll see a variety. I hope we will see a variety of solutions where, again, the EVs are good for this type of application, hydrogen for this other type of application, renewable natural gas, hybrids. The technological neutrality, I think, is key in the automotive, because we got to be really democratic about solutions. And
it's going to take a tapestry of technologies, right? I mean, it's not one technology isn't going to win the day. Even if you legislate a winner, you're leaving a whole lot of capability and a whole lot of industries in their wake, right? So I agree with you. I don't think we should be legislating a winner. I think we should have a democratic approach to the future of what motivates us and go with the best fuel and the best engine and the best whatever for the application, for that drive, for your use case. I don't think that's always considered.
Exactly. So stimulating the innovation, okay, and I think this is exciting. But again, pushing and really forcing sometimes, towards one single direction, I don't think is either practical or ethical. So again, stimulating innovation and really approach the future of mobility with an open mind. And again, there are applications that are good for certain, there are some technologies that are good for certain applications and other for others.
100% agree. Now, looking at the decarbonization to keep internal combustion engines around, because there are going to be Euro 7, there's going to be other emissions goals here in the States and things that are going to have to be met. And of course, you have a heavy-duty commerce market that's going to require a completely different set of needs than the consumer market. Why hydrogen? Why renewable natural gas? And what does that conversion look like? Is it just a different fuel system and fuel tank? Are the engines different? For the enthusiast who likes to understand that, what are we looking at?
Maybe I answer the why, and then I let Mike maybe talk about the conversion side. I think he has a very good example there. So why hydrogen? Correct? Hydrogen, it's a fuel that is very scalable into the internal combustion engine. Correct? You can retrofit existing engines. Let it be gasoline, let it be diesel engines. It can be pretty fast to market. Correct? We have the infrastructure, we have the capital in place to deploy internal combustion engines. We have the maintenance, correct? We have the dealerships, we have the technicians' capabilities. It's very similar to the gasoline engine, so scalability. Second, affordability, correct? It's very affordable fuel systems. If you look, if you take a on-road vehicle with a range of 300 miles, and you look at the total cost of ownership, and you compare the hydrogen to battery electric vehicle, it's 20%, 15 to 20% more cost effective for the end user. So very affordable. Also from the investment perspective, big OEs developing the infrastructure, developing the manufacturing capabilities, it's in place basically. Correct? And third, but not least, is clean. Correct? Hydrogen does not contain carbon, so it burns carbon free. And we talked about, how much is zero, correct? To give you an example, the human, when we breathe out, we generate CO2, correct? And we generate 1 kilogram per day.
That's in your opinion, all of you.
Okay.
So if you could all get
The hydrogen ICE engine, correct? Develop much less than that. Only to put into perspective, correct? You reduce with the internal combustion engine, hydrogen, you reduce basically up to 99.9% CO2 to the environment. So only to keep things into perspective there. But now to the conversion question, I'll let you, maybe you, Mike, explain to that. I think we have also great experience. We have a van running in Europe on hydrogen, officially on the street. I've been with a van at the parliament in Brussels, educating the parliament people, about hydrogen. But I think, Mike, you have also a great example here.
Yeah, so
in my group, I'd also like, in your answer, talk about the cost effectiveness of it. What are we looking at? What's required, but is it, in the grand scheme of things, is it like bolting on a supercharger? Is it like an engine swap? Is it more? Is it less?
So, unlike these guys, who are the big corporations and everything, I'm a hot rodder. Right? I'm a guy that owns a couple companies, and my wife and I made a decision that we were going to fund the development of this, and we were going to work towards a solution that saves our industry, saves what we love, saves, probably nobody in this audience is their vehicle stock. You all got a different exhaust on it, or you got some, something for performance, you got handling, you got all that stuff, right? You're my people. This is where I live every single day. So when we went down the hydrogen path, there's a lot to learn. There are a lot of what I'll call experts on the internet, and I'm using that term very, very
Both of them.
right. So, but if I
Just go to Wikipedia, but give me 5 minutes to change the entry.
if I had listened to them, we'd have never went down this path, right? And even today, there are a lot of naysayers and a lot of people that want to tell me what I'm doing that it can't be working, and it is, So, but hydrogen, there's more raw product to make hydrogen from than anything else in the world. Okay? It's basically made with water. H2O, separate the O, and you got H2. It sounds really simple, but that is truly what it is. Now you can do that in a multitude of processes. It traditionally started with gray hydrogen. Gray hydrogen is made by, most of the time, either using natural gas or electrolysis, where you create a plate and then charge and then separates the molecules. You bleed off the oxygen and release it to the atmosphere. Okay? That is ever changing. So you talked briefly about, I don't think there's anybody in this room that doesn't see a massive push from our government towards electric vehicles, right? A couple of the guys brought up that you don't put all your eggs in one basket. And believe it or not, you probably won't hear it anywhere but here, the government isn't. In the latest infrastructure bill, there was $3 billion allocated to hydrogen development. Okay? So they haven't put their head completely in the sand. They're working they understand that there's more required than just what electricity can deliver. Now, it may have only been 2 people in the room of 100 that got that added on, like they did 60 million for whatever. But anyway, they realize there's more to it. In our case, in my case specifically, we did a lot of analytical work up front before we built our first engine, before we built our first vehicle. You studied analytics. These are all engineers, right? I'm a pseudo-engineer. So.
And I'm just a dumb automotive journalist. So.
I'm not an engineer. I'm coming out.
Don't tell me with that brush. A bunch of really smart guys, right? And engineers use analytical before they do anything. You want to understand, is there the potential, can it work? And obviously, when you do that, it sets up parameters and it sets boundaries and it sets a definition for where you want to go. When we started down the path, we knew that there was opportunity to do things, as an example, like get extremely high exhaust gas temperatures. We knew that there was a potential to cause engine temperature areas and challenges. We knew that there was the challenge. We did a supercharger on top of the first engine, so we knew that there were advantages and challenges to doing that. Okay. We studied all of that analytically and looked at all of it. So we built an engine, I built an engine with safeguards because we knew it was development. We knew that it takes one computer click and we could drive the exhaust gas temperature to 1800 degrees F. We knew that we could potentially detonate the engine. We knew all of those things. So we built an engine that was under kind of the best racing practices. I worked with some of the top companies. I went to Weisco and said, I want to do a different rod. And they were like, what? And I said, I want to run a heavier piston. And nobody runs a heavy piston. Well, I got a plan for temperature, right? So we did all of these things to build an engine. And we got it running. And I have to tell you, the first time that we fired it, it would only idle. We didn't have any other controls in the ECM. And when we got it to idle, I stood behind the truck and it ran. And it sounds just like a gasoline burning vehicle. But there's absolutely no smell. None at all. And I stood there behind that truck and a feeling came over me. It was so surreal to say, I think we potentially just changed the world with what we've done, okay? Now, we've got a whole year of development in that truck. And I can't even tell you how much time it's spent on my chassis dyno. And as we burn tanks of hydrogen through it like you're giving them away. And by the way, they don't, but it's still cheaper than gas. Anyway, we've had great success. The things that we've learned, one thing we've learned is that we don't need all that stuff in the engine. We don't need forged pistons. We don't need forged connecting rods. We don't need a billet crankshaft. We don't need piston oil spoolers. We don't need other advantages.
Yeah, but all those things are really cool.
Yeah. Are they valuable to have? Absolutely. As you start trying to target 600, we have a plan to build, we're going to see how much power we can make with another engine we're putting together. And our target is at 12 to 1400 horsepower.
What's the power density difference between, say, gasoline and hydrogen? And is the power potential the same? Is it greater? Do you have to do more to get more?
Yeah. So let me finish this thought and I'll answer that. We'll debut another vehicle at 11 o'clock this morning. It has another advancement in technology, something those guys are already ahead of me with, but it'll have an advancement in technology, at least part of it. And we'll talk about that today at 11 o'clock. But it is a bone stop out of the crate engine, okay? So, and our technology will work with that. And that's important when you're gonna retrofit. People won't have to build all new engines to do this. We'll be able to take your existing platforms, convert them to our hydrogen injection system, take control of the ignition system and operate it into parameters that we've proven and what we continue to develop, and we'll use that. So that's my personal goal. I want my grandson to be able to drive my wife's 72 SS Chevelle with a 508 cubic inch big block engine, right? I want him to have my 1500 horsepower twin supercharged 69 torque, and I want him to be able to drive them.
Mike is going for Grandfather of the Year. This is clearly his pitch right here.
Do you want to cover? One of you guys want to cover?
Even if you were thinking clean sheet though from an OEM world, the engines are very similar.
Yes.
You don't need to do a whole lot different if you're starting from a clean sheet. The bottom end's the same, the valve train's the same. You probably change your compression ratio, so your piston's slightly different. Obviously it's a different fuel system. You may swirl or tumble slightly different, so the head would be different, but the whole thing is very similar to what you'd recognize as a stock ICE engine today. So there's not a whole lot of change or development that needs to be done.
Yeah, our biggest change was camshaft center line. So we opened the center line up, we're at 122.5, and we did that because hydrogen does not like revision in the intake. So if you've got a great big thumper camshaft in your motor, you're probably going to have to change that when we convert it to hydrogen. But overall, we've had, where we're at, we've had zero issues with revision. I can answer it, anybody else can answer it. Hydrogen contains approximately 3 times the energy per given volume of gasoline. Okay. It also burns at approximately 3 times the rate. From an octane perspective, and you don't measure hydrogen with octane, but from an octane perspective, you can run Previously, an engine much like what I have had been done. They had a lot of challenges because technology wasn't to the point. But they run as much as 25.5 pounds of boost on a V8 with hydrogen. Now they only made 128 horsepower, which is quite interesting, but we're well past that. We're only at 9.3 pounds, and we're over 400 on the tires. So, and we're injector limited. We'll have production injectors in about 8 weeks.
I think one aspect that is that I think we need to talk about as well with hydrogen is the tank, right? Which has to be pressurized. So I think most of the tanks are targeting to be about 700 bar, which is what 5,000 or 6,000 psi. And these tanks are usually built out of carbon fiber. They're actually fairly large in volume. So this is actually a constraint and a challenge that I think the industry will have to tackle to be able to transition to hydrogen.
Is part of that because of range?
In order to match the range of a liquid fuel tank, the volume actually is quite a bit higher. So in terms of the mass of hydrogen, it's really, really small, it's really dense in energy, but the volume of the tank is one of the challenges that we'll have to overcome. So when you look at, so in our case, we are looking at the heavy-duty truck market, right? We actually have a truck running our opposed piston engine in California in the Walmart fleet, and we are doing some development on diesel now, but we're looking at what it would take to actually run this engine on hydrogen. And even if the hydrogen itself ends up being very expensive, the storage and the management of the hydrogen is actually quite complex. So making an engine efficient on hydrogen is also something that needs to be taken into consideration. So when you look at conversions or spark ignition considerations, I think there is great opportunity for more power. But in terms of efficiency, there are some trade-offs. I think when you transition from a diesel engine to a hydrogen engine, you want to preserve the efficiency of the diesel engine, maybe go even beyond that. So keeping the compression ratio high and finding a way to avoid any limitations from knocking or auto ignition actually is a challenge that has to be taken there. And there are opportunities to go with hydrogen on compression ignition without spark plugs, without the issues of auto ignition, to actually go much beyond the efficiency of diesel engines as well. And I think efficiency for the truck market, for the heavy truck market, is really important. This is also another aspect I think that is a great opportunity with hydrogen.
And maybe to add to this one, I think on the tank side, the fuel cell colleagues have done a lot with tank management, right? They have already solutions for passenger and light vehicle and also commercial vehicle side. I think we can scale the lessons learned there, for the fuel cell into the hydrogenize. From the engine architecture perspective, to answer your question, correct, it's very similar, right? You have a regulator between the tank, and the fuel injection system. You need the regulator to regulate the pressure, coming from the tank. You have a fuel injection systems consisting of either broad injection systems with high flows, or now we're going into the high direct injection systems. And pressures, for PFI below 10 bars up to 300 bars in direct injection side. Then you have the controls, of course. You can convert fairly quickly, if you have a dual master approach on the ECM side, right? You keep the vehicular on one, and then you separate the injection, and this is how you get quickly, to a conversion on the hydrogen side. So I think lots of potential, lots of excitement to come. As I said, there are challenges in hydrogen. Hydrogen is very dry. It's a very dry substance, so it combusts completely different than diesel and gasoline, correct? So the effect to the materials are very important, correct? In terms of durability aspect. So we are still learning, we're still developing, we're still investing, we're working with OEMs, with universities, to really get to the bone of this technology, also to make sure we have a sustainable, correct, reliable technology in place. But I think the tunnel is getting bigger, I would say, the light is getting bigger. I've been talking, to a lot of OEMs across the globe, and they've been now realizing, correct, putting everything on or putting all the eggs in one basket will not work, correct? And they have to be open to this technology. They have to be open to invest, correct? Because there's still a lot of investment we have to do to really bring this technology sustainable.
So we talked about the aftermarket conversion. Going back to tier 1 OE, what is the displacement needs for hydrogen with a comparable gas engine? And I know you guys have talked about other things, especially at BorgWarner, of electrifying certain accessory components on the engine to help with the overall emissions and whatnot. What are some of those things that are going to help a internal combustion engine be viable? And then again, back to displacement, just curious, one for one, what would you need if you had, let's say, Mike talked about a Hemi, a 5.7 today, what would that look like in a hydrogen vehicle with the same performance of it?
Maybe I start very quickly, correct? So hydrogen can run on any type of engine, correct? We are actually developing engines from 1.2 liter up to 15 liter on hydrogen. Okay, very diverse, applicable for passenger car up to heavy duty, long haul trucks, correct? So it's very diverse, depending on the conversion, you can also be quicker. Depending on your flow rate that you need, you can also scale the injection side. So from this perspective, I think very flexible fuel to get in any type of application.
Here's the thing about hydrogen. When you do it in a port fuel injection, you have to physically move that hydrogen in through the port into the combustion chamber where you light it. It takes, depending on the application and how you do it, but in round numbers, it takes about 20% of the port volume to physically move the hydrogen. Because realize it displaces air. So you're trying to move the hydrogen and you're trying to move the air through that port. So from just a normal, naturally aspirated, port fuel injected application, works a little bit either way, but about 20% reduction in power, okay? You can put boost on it, you can do all those things. It loves boost.
Is you're helping move it along?
Yeah, you're just forcing more through the hole, right? So in a direct injected application where we spray the hydrogen direct into the cylinder, in those applications, there's virtually zero loss. And we have a technology that we'll announce it at 11 a.m. today in the Red Line Oil booth that actually we're increasing the performance over gas engine. So there's a lot of opportunity. There are so many smart people working on this, and it's coming so fast. I mean, and from an infrastructure standpoint, I mean, when I started a year ago, there was one center in Michigan that you could get hydrogen at that was open, 3 months out of the year where you could get in there and get hydrogen, right? So today, most people don't know it, every Amazon distribution center in the world and every Walmart distribution center in the world, all of the high-lows run on hydrogen. It's all manufactured on site. There's a company called Plug Power that builds all their systems. I have access, Plug Power, I've worked with them and they've now given me access. So as we continue to grow that, I have access to a few of their centers. But in the future, I'll be able to drive into any Walmart distribution center or any Amazon center and plug in. And one of the things that he talked about, which is really important, I think both of them did, about volume, right? I have a 5.3 kilogram tank in my truck. It's DOT certified. They manufacture tanks in 4 levels. Level 3 or level 4 is what you use with hydrogen, because hydrogen is the smallest molecule and it will permeate through. As an example, if you did a standard stainless steel fuel line like we do in hot rods all the time, hydrogen will just escape right through the stainless. So I run a military spec line and everything I do, but
what's it made out of?
I can't tell you.
We're all friends here, right?
I will tell you it's rated for 12,000 psi, and we're running at 350 bar, which is 5,074 psi in the truck. That's the lowest kind of level that they run at. As you increase the pressure, Most fuel cell cars today run at 700 bar, which is like 10,150 psi. To fill to that level, my truck fills in about 5 minutes, from empty to full. So
How much range does that give you?
we haven't run it long enough to know that analytically. We're between 4 and 5 hours of normal drive.
So that's pretty comparable to what's up there.
So somebody asked me to comment on a video that was on YouTube with somebody just talking negative about hydrogen, how impossible it is, blah, blah, blah. How we ever get 300-mile range, the tank's gotta be so big.
Please tell me your clapback was a burnout.
Yeah. And I might be known to do those. But anyway, it's like,
There go your emissions.
you know, let's take your electric vehicle and we'll take my hydrogen vehicle and we'll drive, and maybe I get 250 miles of range and you get 300 miles of range. I'm gonna fill in 5 minutes and be driving down the road. If you hit a fast charger, you can get to about 60% in about 45 minutes. If you go on a standard charger, they time it in days.
Yes, miles per hour, and how many miles you get per hour. Yeah. So you're 8 miles per
If you're
hour.
on a standard 110 charger that you use today in electric vehicles, if you spend an hour and a half on that charger, the next charger has to be a mile and a half away if you're gonna hit it. So I have a place up north, and one of my neighbors showed up with a Tesla, and he drove it about 200 miles to get there, and it took 4 days to charge it.
To make it back.
It goes back to the fact that, okay, there's certain applications that they work for certain type of, like
Absolutely.
activities.
Inner city driving, it's perfect, right? Because you can charge all the time, all over the place. But if you're going Detroit to Chicago and back again,
Yeah, I mean, I think if your range is essentially 100 miles,
Yeah,
kind of from your base, so let's, for those of you from Southern California, that's San Diego and back, right? Then you're probably fine. But if you want to extend that to Phoenix, Las Vegas, San Francisco, that's going to be a different use case. In fact, when I tested the Rivian, one of the issues that we had was it seems like 25% of all chargers are broken already. And now you're starting to get lines of people at the chargers, and fast charging can take 45 minutes, but for example, like on an F-150 Lightning, Ford will fast charge you to 80% and then stair step you all the way down because they don't want to mess up the chemistry of the battery. So when you plug in, you may be at a 350 kilowatt charging station. Well, it doesn't have a charger on board that can take that much power. And it may say, 15 minutes. And then after about 40 minutes, it's like an hour, to get that last part. Or even, most standard homes with a 32 amp charger, which is about 7 kilowatts or so. For most vehicles with big battery packs, maybe an F-150 Lightning, you're looking at 12 plus hours on a home charger. 7 kilowatts versus 350 kilowatts at a commercial station is quite a difference.
but if you're using it to go to and from work, and you can charge at home and at work,
Yeah, if you're charging every day,
then it's perfect. Yeah,
then it makes sense.
Horses for courses, though. Yeah,
Here's the thing most people never think about with electric vehicles. The biggest challenge to charging electric vehicles is temperature. When you charge those batteries, they generate heat.
A lot of heat.
I did a parallel hybrid program actually with Ricardo years ago when I was in GM in Advanced Technology Vehicles. And so we did battery packs that ran 2 electric motors that were integrated into a front wheel drive manual transaxle. So, and the biggest struggle with the whole thing was charging the batteries. So we actually had to put cooling systems in the battery pack. And every vehicle today has that has a battery pack.
They're talking about fuel stations now as well, though. So to get a super fast charge, you will plug in to cool the battery as well as plugging in to charge it. So they are thinking about that. It's coming. But
If you're sitting in some of the cars today and you go to charge it and it's 105 degrees outside Baker on your way to Vegas in summertime or whatever, your vehicle some of them use the same cooling loop for HVAC as they do for the batteries. And so you'll be sitting there charging in the heat, you won't have AC because you're creating so much of a thermal load.
You'll be charging yourself as well.
Yeah, exactly. So, that goes to some of those challenges. I overheard a family who just bought a EV talking about that exact thing and not realizing that they wouldn't have cold AC while they were plugging in and charging the battery on a hot day. Motor Trend, we drove Rivian cross country, all off-road from the Pacific Ocean, or from the Atlantic Ocean to the Pacific Ocean on the Trans-American Trail. And we would pull off the trail to charge, and there's some of those learnings that you had. So it's not bad. It's just not for that particular use case. And you gotta have a lot of patience.
Yeah. Now, talking about range, important is also the speed you go, correct? When I can go 500 miles with 20 kilometers an hour, doesn't help me. There was a study done in Europe, actually, 400 kilometers with an average speed of 130 kilometers an hour. And they compared a BEV, battery electric vehicle, a fuel cell, and a hydrogen vehicle. Number one, hydrogen. The only application they were able to sustain 400 kilometers, 130 kilometers per hour with a light duty van. Correct? Second, fuel cell. Third, BEV. So it's important, correct, to keep in account, the style, the driving style, the speed to drive, correct? But you can get 500 miles, it'll take you significant time, which is not practical, is not applicable, right?
When you look at driving cross country and this kind of leads into my next question for you guys, but driving cross country, when we had the Rivian and the Lightning, I go to Colorado to see friends once a year. And so I planned it out just out of curiosity, what it would take to go from Los Angeles, Colorado to Denver, which is about 1,000 miles. And what's interesting is your strategy for fueling on electricity is completely different. When you have gas, diesel, hydrogen, you go to 10%, 5%, you stop for 10 minutes, 15 minutes, you go back up to 100%. When you're on an electric vehicle, because fast charging only works to about 80%, is now you have to start planning your trips where you're not getting that full 300 miles of advertised range. You might only be getting 250 miles of range, charging to 80%, and then going down the road, charging to 80% again, charging to 80% again. And you look at each one of those as a 45-minute stop versus a 10-minute stop, and you look at how much that adds over the course. There's a completely different mentality that you have to have for doing that. So going to cross country, you guys, we're talking about obviously hydrogen in ICE vehicles, but when we're talking about like over-the-road trucks, there's also the fuel cell conversation that's happening right now. Maybe compare for the crowd the difference in hydrogen ICE in a mega versus hydrogen fuel cell. And I think one of the reasons, in my opinion, that fuel cells are getting traction is because the discharge of power for pulling 80,000 pounds up a grade is a lot easier from a fuel cell standpoint than to discharge that from the battery storage standpoint in an EV. So how does hydrogen with internal combustion match the performance of hydrogen with a fuel cell doing the same work? It's kind of an interesting thing I'm wondering.
It's tricky. I think one of the big advantages a fuel cell has is it's more efficient. So when you're talking about Class 8 heavy duties, it's all about efficiency. And at the moment, fuel cells are around 60%. I think we're projecting hydrogen ICE to be maybe 45-ish. So that's quite a big difference. There's some benefits for ICE, though. Obviously, we've talked about the fact that it's a known technology, it's robust, it's reliable. It's also much cheaper to implement. That's again important when you're a working truck. And one of the other big differences is fuel cells need to use really, really clean hydrogen, top grade pure hydrogen.
Very sensitive.
Very sensitive. An ICE engine, an ICE hydrogen engine can take pretty dirty hydrogen. It's pretty tolerant of particles and that kind of stuff as well. So there's pros and cons for both. I don't think they necessarily should compete. If you can get both of them, get them both to have traction, use them both to get the infrastructure nationwide, then they're both going to benefit from that. I don't see them as competing particularly.
Fuel cell is zero emission, so it can fit in that category clearly better than ICE. But yeah, I think again also here variety of options.
Yeah, absolutely.
Zero emission depending on where you snap the chalk lines.
Exactly, that's what I'm saying. Like,
It's a bigger tailpipe.
Do you guys know what fuel cells are and how they function? Does anybody know that? Because most people don't really understand what a fuel cell is. So a fuel cell is basically a membrane. You burn hydrogen, as it travels through it generates electricity. There's a battery pack in a fuel cell vehicle. It stores the energy that feeds electric wheel motors. So it's basically a recharging system for an electric vehicle, to simplify it. They work really well. They what?
It's no different to like a full hybrid ICE engine.
Exactly.
It's a generator.
Yep, it's a generator. So the advantage is, and one of the things that really helps in fuel cell is they have a battery pack. So if you read data on distance with fuel cell compared to comparing it to an ICE engine, what they calculate in the distance, or they measure in the distance that the battery pack gets you, and then the additional that the fuel cell creates for charging that battery pack to keep you traveling. So that is a plus without question. In particular, for the truck and everything else. I really thought, and still, until what Cummins has done, and they've, everything they say and everything they talk about is phenomenal for what they've done for their new engine. And until that point, I personally thought fuel cell would be the way most heavy truck would end up, because they can travel that quick.
Yeah, I have a very personal point on fuel cell. I think that there's still a lot of work to be done on fuel cell when it comes to reliability. I think on the concept side it works. On the reliability side, still a lot of work to do. I think that hydrogen ICE can bridge this thing fairly quickly to get us to really carbon neutral environment much quicker. Fuel cell will eventually get there, but if you look at those systems, they're fairly complex. Correct? Fairly complex, completely different technology to an ICE. You need basically people, educating, to be able to manage this, to maintenance those fuel cells. It is not going to get there. I think for the reliability standpoint, this is what the OEs are realizing right now. Right? Yeah. They say, oh, we are stuck here a little bit. How about the hydrogen ICE? If you look at the development of hydrogen ICE 18 months ago to now, it's tremendous, correct? We are working, Work is working on more than 70 development programs on hydrogen ICE. A year ago, we had only 5, right? So you can see the scalability of this, the need, because people are realizing, oh gosh, this does not work, right? This will not work from the whole ecosystem perspective that we talk, from the whole society perspective, will not work with the challenges, and we will not get there as quick as possible. And hydrogen ICE can get us there.
I like the bridging, bridging. It's a known technology, hydrogen ICE, or ICE is a known technology. So let's use what we know and then let that bridge to whatever the future is, and it lets us all develop all the other technologies in the background without putting all your eggs in one basket and dropping it.
Fuel cells are also very fragile. It's very easy to damage the membrane in a fuel cell.
So we've been putting Class 8 fuel cells in Class 8 trucks for the last maybe 4 or 5 years. We've got, 6 or 7 of them rumbling around, and they work. But you look under the hood, and there's a lot going on there. It's not simple. There's a lot of stuff under there that you need to keep them working and keep them running.
Expensive development.
Yeah, it's not cheap.
I agree with all the challenges. Federico, you mentioned, carbon neutrality and bridges, and I think, that's key. Like how you need something good or better now. Okay, while we develop certain things, and for example, carbon neutrality, renewable natural gas, you get net zero emission, even negative emission. And this is also nice.
We need practicality, right? We need practicality, something you can basically implement quickly, fast, into high volume. We need help, right? We need help from the government. We need help from the legislature to make this work, to fund this as well, right? There's still a lot of work we have to do. And we have genius people here like Mike, right? They are investing their own
An old
time,
hot rodder out of Detroit.
right?
And grandfather.
And corporations like we are, right? They are believing in it, and we need to drive, right? We need to continue to drive.
So we've got about 5 minutes. We can open. We probably have time for a couple questions to finish up. So is there an extra mic, Mike? Rob, if you want to just grab a couple people. We'll probably only have time for 2 or 3, so I see you 2 gentlemen right there.
I've heard a lot about bridging and not all of the eggs in one basket and so on, but there hasn't been any real discussion about plug-in hybrids. In the sell-up of EVs, everybody was saying, oh, you only need 30, 40 miles, that's the deal with you. Why not plug-in hybrid that'll give you that, 30, 40 miles of EV battery mode driving, and then have the ICE on hydrogen, so you're totally, zero EV.
Maybe I can comment on the plug-in hybrid versus the pure EV. So first of all, the plug-in hybrid requires a much smaller battery, right? So you can have maybe 10, 20 plug-in hybrid versus one EV. When you look at some of the batteries from some of the Rivians and the Hummer, it's like 150 to 200 kilowatt hours. This is such a major strain on the environment to make this battery.
For example, a Wrangler 4xe or a Grand Cherokee 4xe, which is bought one, so very familiar with this conversation, is 17 kilowatts.
Yeah, 17 kilowatts.
Yes.
Yeah, the weight is certainly a big factor which we haven't talked about in terms of electric vehicles. So the idea is you can really spread out this impact over many more vehicles and leverage still the day-to-day benefits of driving zero-emission vehicles because you can plug it every day. One of the thing to really understand, and we talked about that earlier, is when a electric vehicle is produced, it has already emitted the CO2 emissions for most of its life. I mean, basically, I think some of the light-duty pickup trucks with 100 to 200 kilowatt-hour batteries have already emitted the CO2 that will take about 150 to 200,000 miles to recoup. So they start with a negative impact on CO2, actually an adverse impact on CO2, and they have to recover.
And to that point, kind of an interesting conversation I was having with another journalist was back in 2004, 5, 6, 7, 8, Hummer was obviously a brash in your face American brand right until the economy crashed. Then everybody made it the poster child for inefficiency. And you look today, the new Hummer, which is like, well, we can do it today because it's zero emissions, except for, I think that at some point, that pendulum's going to swing the other way, and it's going to be, you're the poster boy for the most inefficient EV vehicle, and you're wasting electricity. So it's interesting how these things come full circle over time.
Well, and to answer your question, one of the biggest challenges is the complexity, the cost, okay, and then the sheer mass that you generate when you start doing those systems. So the Volt is very much along that line, except it uses a regular gasoline burning ICE. The problem is you've got two complete powertrains. So you can run a smaller battery pack because you don't need as big, but you still have all of the electronics to run it, all of the complexity. Now you have to integrate the two to work together so that the vehicle knows when the battery goes low to start the engine, all of the other things. The cost gets out of control very rapidly when you start doing that.
But your ICE engine can be very small and very cheap, and it'll just hit that sweet spot in its range. And we have a Magma XEV concept. It's a single cylinder engine, but it's high 40s, 40, 47, 48 plus % BTE for a gasoline engine, because it just has to run at that one sweet spot. Right. So it can be as a holistic vehicle package in the right circumstance. I think it can be quite effective.
It could, but it's not very well accepted. Basically anywhere in the world right now.
It might be the media spinning, right?
Yeah, well, you know.
Well, I think actually California will still allow, I think, 20% of the zero-emission vehicles past 2035 as plug-in hybrids. They have to have at least 15 miles of range to be considered a zero-emission vehicle. So there's some opportunity.
Hopefully they're all going to have my system in it.
I give a really quick answer to you. I like hybrids. I even like more, hybrids running with hydrogen ICE. And we're going to have a demo vehicle next year, a hybrid running on hydrogen ICE.
It's going to be exciting because I think that's a really viable path forward. So if you want to ask me a question.
Yeah, greetings. My name is Eagle. Do we have a mic?
Yep. We can hear you. You can just talk loud.
Just bear with me. Testing 1, 2. Okay.
Yep.
Okay. My name is Eagle. I'm here in Las Vegas. I'm a local engineer. I'm here with my crew. We try to develop many different integrations and trying to be efficient, and of course we're pushing that low performance. So my question to all of you gentlemen, if you can add some insight, since steam has not been really fully developed, in my opinion, considering the technology we have, do we have an integration package where we can include steam into a regular ICE combustion motor that we can help maintain the carbons or maybe help clean it and maybe help it last longer, especially in an environment out here where the humidity is so low. And granted, we don't have freezing temperatures. So I was wondering if there could be areas in the country where that would apply. Just like electrics apply in certain things and diesel apply in certain other things. Why not expand all the options and have an integration package where we can still save some of the old motors without the costly effects? What if we don't have the technology to get hydrogen in our town for in an undeveloped area of the world or undeveloped country? So we'd like to know if you can expand a little bit more on the steam technology and what's available for integration.
Well, I know that there has been some studies done on steam, and packages. There, I think that the main challenge is the performance, getting performance out of the steam, out of the energy. The energy content is very low, so you need a lot of additional flows, to get to the performance you want. I think you need to be open to this technology, correct? I think if you're open to that, I think explore. I think you can get there. This is, I think, from my side. I don't know if the others have experienced something about steam. I know that obviously it comes from the back, but getting to the performance and efficiency, I think it's the topic.
Yeah, my experience, I rode around Burbank with Jay Leno in his steam car. That's about the extent of my steam experience.
I did that once. Told my mom.
You would think it would clean the system out in the process, yes, no?
Anything's possible. I think he put it best when he said that you never want to just look at the negative or the potential negative or challenges in anything and say that couldn't work, right? I mean, 2 years ago, 2.5 years ago, I might have questioned hydrogen, right? Unlike the people that question my sanity when I told them.
All right, not to cut this short, I know we're over on time. Everybody has places to go. I just wanted to give each of our panelists opportunity, just one last thought for the group here. And then for those of you who are heading out right now, please remember to take the educational survey, or SEMA educational survey. The QR code should be available to you. But if each of you guys would like to say one last word about this topic.
No, I think for you, I think we need to continue with the vision of the ICE engine, correct? I think from my perspective, the end is not there, absolutely not there yet. It will continue to enhance the technology. There's much more work to do, and I'm really looking forward, to get to the next levels of the ICE engine here, together with you and together with the industry. Thank you.
Yeah, I think one thing I wanted to say to kind of close this up is, it's our responsibility, the people that have the knowledge, that have the understanding, now you do, maybe you did already before, is to spread the word. Help people understand that zero emission vehicle is not zero emission vehicle, because when it's time for them to vote, when it's time for them to lobby, they need to have that information. We need as an industry to really say what is the right solution, not just ignore it.
Well, I appreciate all of your interest and all of you coming and doing this. Really smart guys here with me. If you're at 11 o'clock, we will debut a new technology in the red line logo, 22517 is the booth number. If you want to come by, we're doing a little press conference, and we'd love to have you and share with you what we've been working on.
I think, to quote Kelly from Convergent Science, that the future is eclectic, not electric. So that should be the focus.
I like that.
That's good, right?
Perfect. Well, first of all, thanks to SEMA for this opportunity. And sorry, because you mentioned Steve and you mentioned Jay Leno. I live around Burbank and actually saw the car, but that's also as much as I can explain about
Hey, I got to ride in it.
But this is great actually, because we got to be open-minded, when it comes to automotive and eco-mobility. So I think again, it's key to be to stimulate the innovation, okay, and to be technological, neutral. So the automotive business really needs to understand that, okay, we need to embrace all kinds of technology. The common denominator now is sustainable transportation. There's a lot of ways to get there.
Awesome. Well, my name is Sean Holden, and on behalf of SEMA Education, and of course Federico and Toby and Mike, Fabien and Andrea, thank you guys. It's been an amazing conversation with you. Hopefully you guys found it to be really interesting. And again, if you wouldn't mind taking the SEMA Educational Survey, we really appreciate that. We take all that feedback and probably seriously to keep having these types of information transformational programs each year at SEMA. So thank you, everybody. Have a great
Hey y'all, make sure you subscribe to this channel and visit ScottieDTV.com for an easy way to search the hundreds of videos I have posted. Either click the link in the description or the one at the end of this video.